Okay, this is our second geometric sequence video, so I've go back and look at the other ones. We're going to look at how to, given these different formulas, I'll do some of that, and then we'll talk about the two application problems. We'll see how far we get. On this one, this is the recursive formula. Here's an explicit, recursive, explicit. I'll do these two. So we have 6, and this is our first term, and then we're multiplying it by 2. Okay, that times 2 is 24, that times 2 is 48. Done. Okay, this one, if I think about it, I can plug in 1, and that means I'm raising this to the 0 power. So the very first term I'm going to get is 7. And then I recognize that I have my common ratio here of 3, so I'm just going to multiply by 3. Multiply that by 3 is 63. Multiply that by 3 is what? 189? How did I do? I don't know, something like that. I wanted to point out another thing that I forgot. Okay, so if I look at, let's come back to one of the ones from the top. Okay, let's do this one. This 125, 25, 5. If I want to find the nth term with this one, what I was saying this, take the first term, and then it's the common ratio is 1/5 to the n minus 1. What we can do is that we can say it's also possible to if I did this, 625 to the times 1/5 to the n, what would happen? Well, that means the very first term, when I plug in 1, this is a sub n. So a sub 1, when I plug that in, I have 625 times 1/5. Well, a fifth of 625 is 125. And then a sub 2 would be 625 times 1 over 25, is that squared. And that divided, that's just 25. And then if I were to say a sub 3 is equal to 625, well, this is 1 over 125, that divides out to be 5. Notice what I have here is that it's possible, you have to be careful, is the short answer. It's possible to write this equation either way. So I could come back, and this would be like the 0 term, and then just leave this as an exponent of n, or I could use the first term and do that. Here's the short answer. This is a perfectly acceptable answer. This is what I would expect you to write for me. But there are times when you will see me give you a formula where this is not necessarily the first term. So you have to pay attention and check to see what your exponent is right here. Notice this exponent doesn't match that one, so therefore this is not the first term. This is a little more like saying a sub n is equal to a sub 0, which we didn't even make our list, times r to the n. Okay, so be careful with that. That's not always the first term, but always plug in 1 to see what the first term would be. Notice plugging in 1, this goes to 0. That means this whole part goes to, there's the bell. This whole part goes to 1, and so then that's that first term. I hope that makes sense. But on this one, if you plug in 1, you actually have 1/5 that you have to multiply by. Let's talk about the rabbits. Okay, so this I wrote this problem when I had a huge rabbit problem in my backyard. They seem to have gone away, so I don't know what the difference is. But it says 1 square foot is covered in droppings at the beginning of week 1. How much will be covered at the beginning of week 8? Oh, wait, it doubles every week. So that common ratio is 2, and so my a sub 1 is equal to 1. So my formula a sub n is just equal to, well, 1 times 2 to the n minus 1. So at the beginning of week 8, 1 square foot is covered in droppings at the beginning of week 1. So at the beginning of week 2, we now have 2. So at the beginning of week 8, that's going to be a sub 8. So it's 2 to the 7th, which is what? Then we go 2, 4, 8, 16, 32, 64, 128. So there's 128 square feet of rabbit droppings in my house based on that problem. So lovely. The next one is a good little problem that warrants its own video. So go check that out in another video.